2.2, verifying trig identities. So, guidelines. These are things you should come back to if you find trouble with where to go next. Okay, so these are basically like different thinking processes when we're verifying trig identities. So work from one side to the other. Typically start with the more complex side. It doesn't matter which one is equal to what. You can start with either side and work to the other side. If you're given two fractions, you want to find a common denominator and try to simplify that as far as possible. If you're given a fraction, one fraction, try to multiply by the conjugate on top and bottom and see what that may give you. If nothing else, you can always try to change the sine and cosine. I wouldn't start with that until you went with these three first. And last but not least, once you do these three, try to look for Pythagorean identities whenever you have something squared. So looking at this first one. First, which side is more complex? I would say this side is more complex. Right away, though, I see a secant squared. So if I look, secant squared is going to be equal to 1 plus tangent squared. So I'm going to first change out what secant squared is. So instead of writing secant squared, I'm going to write 1 plus tangent squared. And now by doing that, I notice that on top of my fraction, this 1 plus minus 1 is going to give me 0. So now I have tangent squared theta over secant squared theta. So now this might be a good indicator to try to switch to sine and cosine. So just so that you know where I'm coming from, so I'm going to go like this. I'm actually not changing anything yet, just so you know where this is coming from. I can change my tangent squared, because I know tangent is equal to sine over cosine. So this is my tangent squared times secant squared is equal to cosine squared theta, because it's the reciprocal. Now if I multiply these across, these cosine squares cancel each other out. And now since those are canceled, I get my sine squared theta, which was what I was trying to go to. So that is done. Once you go from one side to the other, you're done. So the second one, especially here, a lot of times people try to work left to right. You don't have to work left to right. I'm going to start with the right and try to get to my left. So I have two fractions. And remember, if you have two fractions, you want to try to get this common denominator and simplify. So my common denominator here is going to be 1 minus sine theta and 1 plus sine theta. That's my common denominator. So for this fraction, I already have the 1 minus, so I'd have to multiply on top and bottom the 1 plus sine theta. So this would just become 1 plus sine theta for that first fraction. And then I would have a plus right here. And then here, I have a 1 minus sine theta. I would have to multiply by 1 minus sine theta to get that common denominator. So this would be my 1 minus sine theta. And now, two things that happen here. You should start being able to see conjugates. These right here are conjugates. You could also FOIL this out like that. If you FOIL it out, these two signs cancel each other out. So on bottom, I have that 1 sign. How do I know to actually multiply instead of just leave it? Well, we have Pythagorean identity. So this could be an identity. We'll check it out. But now also, if I look on top here, I have this negative sign and positive sign. Those two cancel each other out. So I'm really going to have this 1 plus 1, which is 2. So now again, if I look at my Pythagorean identities, this identity right here, I would have 1 minus sine is equal to cosine squared, because I can move the sine squared over. So this is going to be equal to 2 over this right here is equal to cosine squared theta. And we know if it's on the bottom, I can put it on top because we have reciprocal functions, which would be secant squared theta. And right now, this is my left-hand side. So that is simplified. So question number 3, I want you to try to do it before I go over it. Try to do it before I go over it. So when you do this, this might have been an easier one to see because this right here can be simplified into secant squared theta. Again, that's a Pythagorean identity. This one is not. Some people are like, wait a second, I would have to do 1 minus cosine. Well, force it in to look like that. So if I factored out a negative 1 here, that would be a positive 1, because I factored out a negative, minus cosine squared x. Sorry, this is an x, not a theta. So now what I have here is this negative 1. And this right here is equal to sine squared, because 1 minus cosine is going to be equal to sine squared x. So again, if I wanted to, now I can rewrite this as sine and cosine. So in this instant now, because I'm trying to get to tangent, I would rewrite this to sine and cosine, because I already have this sine. So this right here is going to be equal to 1 over cosine squared x times, this is like a negative 1 sine squared x. So if I multiply that across, I'll have this negative 1 sine squared x over cosine squared x. And again, this is another identity. Sine over cosine is tangent. So negative 1 tangent squared x. You don't have to have that 1. You could just have the negative, but now that's the right-hand side. So here's kind of like, okay, which side do I start with? If you have a side that doesn't look too much more complex than the other, start with the side that has adding, subtracting. So I'm going to start with this side. There's no fractions here. There's no squares here. So what we should do is change to sine and cosine. We're going to change it to sine and cosine. So then we're going to force them to be fractions. Sine over cosine is going to be my tangent, plus cosine over my sine is going to be my cotangent. So now I have fractions. So I'm starting with the right-hand side. So now because I have fractions, now I'm going to find that common denominator. My common denominator here would be cosine x times sine x. And because for this first fraction, we do not have sine, we do have to multiply by sine x on both top and bottom. So get that common denominator. So on top, we would have that sine squared x. Over here, we already have sine. We need to have the cosine, so we would have to multiply by cosine x over cosine x. So now that's my common denominator. So we have this plus here still in the middle. And then cosine times cosine is cosine squared x. So now we kind of forced it into a trig identity. So this trig identity, sine squared plus cosine squared, is going to be equal to 1. So this would be like 1 over cosine x sine x. And now because we have this fraction, whenever you have a 1 on top or bottom or just a whole number, that's a little bit easier because we have the reciprocal. So the reciprocal of cosine is secant x, and the reciprocal of sine x is cosecant x. So this right here, we got to the, sorry, we started with the left. I don't know what, left. We got to the right-hand side. So then we're golden. So right now, I want you to try to do this one by yourself. I would first start with this fraction, and I would start with multiplying by the conjugate. If you can't remember what the conjugate is, try to look at what we did for the example earlier when I talked about the conjugate. So try to do this one by yourself. So I multiply by the conjugate, I get this. This now is forcing my cosine squared. So a lot of times people at this point are like, I don't know what to do next. Well, we cannot split up adding, subtracting the bottom of the fraction. And the top of the fraction, we can split that up. So now what I'm going to write is cosine x over cosine squared x, because that's our denominator. We switch that. And we still have this plus sign right here. And this would be sine x cosine x over cosine squared x. So now only if there's adding in the top in the numerator can we split up adding, subtracting. Now this right here will simplify just to be 1 over cosine. So we have that 1 over cosine x plus this cosine and this cosine. One of those cosines can cancel to be sine x over cosine x. Now these are our reciprocals and our quotient identities. So 1 over cosine is going to give me my secant x, and sine over cosine is going to give me my tangent x. So this right here is my final answer. So this problem, a lot of times people might see this and be like, oh, I should do the exact same thing that I did up here and force this into, you definitely could do that. One thing though, if I see something squared and everything else is not squared, one thing I might want to try, I'm going to start off with this left-hand side, and I know that there's a trig identity with Pythagorean identity with cotangent squared. So if you look, your trig identity is 1 plus cotangent squared is equal to cosecant. So if I just want cotangent squared by itself, I could rewrite this as cosecant squared theta minus 1 is equal to my cotangent squared. So this is what I have now. And the reason why that's beneficial for this one, so again, I'm starting on the left-hand side, is, again, we practice factoring, so I could factor this. The reason why I want to factor this is because of the fact of what I see on the bottom of the equation. So if I factor this, because these are both squared, this would be cosecant plus 1 and cosecant minus 1. And I still have this. I can rewrite addition problems as cosecant theta plus 1. So now because of this multiplication on top, what I see that I forced it into, these two cancel, leaving me with cosecant theta minus 1. However, that is not what we have right there. Now from here, there's two ways that would allow you to do that. Either try to rewrite this side to look like this, because this looks nicer than that side, or force this to look like this, even though this doesn't look as nice as this. So one thing I noticed, I'll show you both of these in class, but cosecant is the same thing as 1 over sine. So this is like 1 over sine theta. And if I wanted to, 1 is the same thing as sine theta over sine theta. And because now these two have common denominators, I could rewrite this as 1 minus sine theta over sine. We could have also went from this right here, started with that, and then rewrote it here, and then got the same end result. Either way, this proves this identity here. Last but not least, I'm going to start on the right-hand side because this one looks nicer. So first thing I notice here is that I can take out a tan squared. So I can factor out a tan squared x, leaving me with secant squared x minus 1. And we have a trig identity for that secant squared minus 1. So that is equal to tangent squared x. And now it's tangent squared times tangent squared is going to give me tangent to the fourth x. Pause the video and try to do this one by yourself. So you should have noticed that this had a cotangent that you could take out, forcing this into a Pythagorean identity. So this is equal to cosecant squared x. And so I can multiply those, square times square, to give me cosecant to the fourth times cotangent. And yes, this is difficult. But yes, you get this trig identity. And the more you use them, the more you actually do the homework and don't just write down the answers, the more you think about what do I have and how can I get to the next location, the better off you are. But you have a wonderful day.